Hope this will be a quick video. So this is the summary of lesson 4. So the very first part is saying that the concept of the imaginary point, if you remember, it's over here. We say that it's imaginary because it's not a physical point at the ship itself or at the position of the material we are actually looking at. Okay, so do not choose any reference point of C. So if you are if you're calculating, okay, but if you are doing in terms of in the real life, if you want to convey certain message, the C itself is pretty much a question mark for people to build. Okay, and then we also talk about, and then we start to talk about flow visualization. So you just need to know streamline and pathline. So pathline is the trajectory of a fluid particle at a different time. So as you can see, this one should be path lines. Okay, this one should be path lines. Okay, and then if you were to ask me streamlines, so what are the streamlines itself? It is the so in the other words, path line refers to the line itself. Streamline refers to how steep it is. Okay, so streamline and path line is actually the same in a certain sense. Okay, it's a very deep understanding. Because path line is just the particle along this it can along a certain whatever streamline value you are, because the gradient affects how this whole trajectory will move, right? If you remember. So streamline and pathline, they are actually together, one set. I don't know. I'll leave you to think about it. And then we talk about it quite a lot of time. So after which and yeah. So if you're talking about path line, you can use u equals to dx dt and v equals to dy over dt. But if you're talking about streamline, you're talking about this equation that eventually will go into u is equals to partial xi over partial y, and v equals to minus partial xi over partial x, and then this one over here. So you need to know all these things. Okay, and then what design is actually all about is actually the streamline value. Okay, so yeah, goes to some c. In our case, we actually keep doing about c equals to xy. So in this case, this one will be this xy relationship streamline. Okay, so different streamline will give you a different gradient, that's all. So what will change the shape of this path? Okay, what will change the shape of this is actually the equation. So we also talk about how to derive general equation. Okay, we give you a recommended way. Okay, to make sure that the lawn, if you're dealing with lawn, make sure that you group them together as one side, and then you do whatever shit you want. We also derive how to acquire an equation to describe x. Okay, just x itself and y itself. So you integrate them using the pathline equation, if you remember. So you just use this relationship and then you can integrate, and then you get your equation for x and y with a particular initial condition. Let's say time is equals to 0, you can sub in c and d for your values. So these are all the stuff you really need to know and get into your heads. So this different equation of x and y will give you different shapes. So we also prove that if you were to, let's say at first our shape is exponential, right? This is our x equation. Okay, this is our x equation. So if our x equation is a square root, then you can see that it's going in a different trajectory. It's going in this form. And then we also talk to you about all those things. Nonetheless, this portion is still a little unclear about. Nonetheless, okay, also talk about velocity magnitude. We explain accelerating or decelerating of the particle. Okay, whether is it, so how do we do it? We use back the same, we use back the equation u and v is equals to sum Nonetheless, you also need to understand how to identify which is U, which is Y. Okay, if it's U, then it's in terms of the x-axis, then it is I hat. If it's Y, then it's the J hat. Okay, so you have to be very, very careful. And then nonetheless, we are talking about, so far all we are talking about is 2D visualization. There's x-axis and there's y-axis, right? So this is it. And then we derive a general equation for stream functions using all this stuff. I will go through. It's pretty much straightforward. And also this explanation, although it is smooth, but it is not very intuitively conveyed well. So I'll leave you to find out. So this is actually our stream function. Okay, so the stream function will give you exactly the flow rate between this. So what is the flow rate between this and this? Is this flow rate faster speed than this speed? So yeah, because you need to really go and find it. So the amount of volume over time, it all depends on this equation xi2 minus xi1. You will get the flow rate between them. Okay, maybe this will be faster than this, whatsoever. So yeah, I'll leave you to there, and I'll see you soon. And then now it's 11:31. I can go and do something and sleep. So see you. Bye bye.